Welcome to the content material for Class 23 of Engineering Statics. You should be watching this video before your 23rd class. In this lesson, we will learn how to determine whether an object will slide or tip over as a result of friction and an applied force. In this class, we will continue to study friction. Specifically, we will look at the moment when a body may begin to move. Last class, we considered the point at which an object began to slide as a result of an applied force, and we called that point impending motion. However, imagine we have a tall wooden cabinet, and we begin to push on that cabinet. The rough wooden cabinet will have a high friction coefficient. Depending on where we apply the pushing force, the cabinet may tip over before it begins to slide. In this class, we will learn how to determine whether a body will tip over or slide first. To determine whether a body will slip or tip first, we simply solve the problem twice. We first assume slipping, and then we assume tipping. Whichever answer has a lower pushing force is the option that will cause the body to move. Solving for slipping is what we have learned before. We assume the normal force is centered somewhere under the body. Then we assume that the friction force is equal to the normal force times the static friction coefficient, μs. Once the pushing force exceeds this friction force, the body will begin to slip or slide. So we solve for P being equal to that friction force. Next, we solve for the tipping scenario. In the tipping scenario, we assume that the normal force is completely concentrated on the front edge of the body opposite of the pushing force. In this scenario, we can see two couple moments, one from the weight of the normal force, and the other from the pushing and the friction force. Next, we set the two moments equal to each other, and we solve for the push force. We can do this easily by taking the moment about this point O. Tipping will occur when the moment from the pushing and friction forces is greater than the moment from the weight and normal force. Therefore, we set these moments equal to each other, and we solve for P. And finally, we compare our two pushing forces, and whichever is smaller is the option that we believe will happen first. So let's look at an example of that. Okay, in this example, we're asked to find the maximum force P that can be applied to the grate before the crate will move. So we're asked to determine whether the crate will slip or tip over first. And we're told that the crate has a mass of 25.5 kilograms, and we know where the center of gravity is at point G. So to solve for this, we're going to first assume both of the possible conditions. So we'll start with slipping or sliding. And if we assume that, our free body diagram will look like this. We have the weight, the pushing force P, and we know that the normal force is somewhere under the crate, and we have the friction force. So under these conditions, we'll start by solving for equilibrium in the y direction. In this case, we only have two forces, so we know that the normal force is equal to the weight. So we'll go ahead and plug those numbers in. Solving, we see that the normal force therefore would be equal to about 250 newtons. We can move on to equilibrium in the x direction. We're going to assume in this slipping case that the friction force is the highest that it can be, which is at the point of impending motion, where we can assume that it's equal to the static friction coefficient. So when we solve for the friction force, we find that that would be 100 newtons. And looking at our equilibrium in the x direction, that therefore the pushing force would have to be equal to that. So we know the pushing force under slipping conditions would be 100 newtons. But the question is, will the crate tip over before that occurs? So let's see what happens if we assume the tipping scenario. So again, we'll draw the free body diagram. But this time, the normal force will be concentrated at the front end. Again, we have some friction force and the force P. Now, when we assume this condition, we can take the moment about this point. This is point A. So we take the moment about point A. It allows us to solve for what P would be. So this distance is 4.5 meters, and this distance is 1.5 meters. And we solve for P. So what we find is that for the tipping scenario, the pushing force is actually less than the slipping scenario. So we choose the lower one because that means that it will occur first. As we increase the pushing force P, we get to the point where it would actually tip over before it gets to the point that it would slip. So our final answer is that that pushing force, when the crate begins to move, would be 83.4 newtons. And the first movement it would take would be to tip over.